name is Dr. Tanya Cherukuri. I'm Vice President of Applied NanoFluorescence, where we specialize in the manufacturing of near-infrared fluorescence spectrometers that use visible excitation wavelengths. Our instruments are optimized for the analysis of single-wall carbon nanotube samples, but they can be used with a wide variety of near-infrared fluorophores. We also have options to add absorption and Raman spectroscopy onto our instruments for a more complete sample analysis. Today, we're going to do a demonstration of our NS MiniTracer, which is our smallest and most sensitive near-infrared fluorescence spectrometer. We'll also highlight some of the key functions of our other instruments in our nanospectralyzer product line. I'm here with our NS MiniTracer, which is our smallest, most compact, and most sensitive near-infrared fluorescence instrument. It's composed of three parts: our main optical unit, a near-infrared spectrometer, and then a laptop computer, which is used for acquisition and control. Now, the main optical unit houses a single excitation source. It's either a 640 nanometer or a 785 nanometer laser. The 640 nanometers is excellent for single-wall carbon nanotube samples, and the 785 has been very desirable for people working on near-infrared medical imaging dyes. This particular unit also has the option to do near-infrared absorption in addition to near-infrared fluorescence. So it also houses a tungsten lamp. We can detect near-infrared, both the absorption and the emission, from around 900 nanometers to 1600 nanometers. So I am back with the MiniTracer. I now have everything connected to power and connected to the computer, and we're able to start it up and see how it works. The MiniTracer comes with three fluorescence functions. These functions are accessed through the drop-down menu in the software. The first function is individual fluorescence measurements. These measurements can be acquired either through the auto-acquire, where the software calculates optimized parameters for each sample, or the measurement can be taken through manual acquire with user-defined parameters. The software also calculates the total integral of the emission spectrum and the cursor integral from the wavelength region selected by the cursors to give a quick way to compare between samples. The second fluorescence measurement function is the sequence tab, which allows you to measure the fluorescence spectra of a sample over time. The third function is the calibration function, where users can measure a set of standards to create a calibration curve that is then used to measure an unknown sample in the main fluorescence window. The concentration is then displayed as the total integral. The MiniTracer has the option to add absorption measurements across the same near-infrared wavelength region. This also enables you to build absorption calibration curves and use these curves to calculate concentration from absorption measurements. Our nanospectralyzer product line is a series of multi-mode optical spectroscopy instruments centered on high-quality near-infrared fluorescence measurements. Each model includes sensitive near-infrared absorption and fluorescence measurements. Most also include visible absorption. The number and type of excitation sources varies by model, as well as the ability to add different Raman spectroscopy modules. The NS1 includes near-infrared emission measurements, as well as near-infrared and visible absorption. The NS2 is the NS1 plus a single Raman wavelength, and the NS3 is fully configurable. The NS Super features a white light supercontinuum source that allows for continuous scanning of the excitation wavelength during fluorescence measurements. Here is an example of the collection of excitation emission scan in real time for a sample of HIPCO nanotubes and sodium cholate. The total acquisition time of this scan is about 45 seconds with a signal to noise of about 90. You can use this to rapidly check the distribution of NM types of nanotube samples. You also are able to manipulate the 3D plot in real time to look either at a contour view or a 3D view. And you can monitor either the emission spectra or the excitation spectra during the scan. The Super also has one higher power laser to do trace detection or kinetic measurements, and includes visible and near-infrared absorption, and has an option to add a single Raman wavelength.